The hunt has begun for other habitable planets. The first images from the James Webb Space Telescope have been released. They offer the most detailed and comprehensive view of the solar system we've ever seen. How will that change our understanding of the universe? This is Inside Story. Hello, welcome to the programme. I'm Bernard Smith. We can see further into the depths of the universe than ever before. It's taken decades and hundreds of millions of dollars to invent and deploy the technology we needed to get a better look at the cosmos. But why are scientists going to all this trouble? What are they hoping to achieve? We'll chat to our guests in a moment. First, Rob Reynolds reports.
5 enormous galaxies locked in a cosmic dance. Billions of stars and planets 300 million light-years from Earth. This is one of the spectacular images taken by the Webb Space Telescope, unveiled for the first time.
What you're seeing is just a week's worth of data. Think what we're going to learn in 20 years. Think of the answers that we're going to get to the questions we don't even know enough to know what the questions are today. And in the process, we're going to learn more about who we are, what is our existence in this cosmos. We are looking back in time almost to the beginning.
The image of the so-called Stephan's Quintet shows 2 galaxies colliding and merging with one another, impelled by the force of gravity. One of the galaxies features a bright spot scientists have identified as an active black hole, the gas and dust lighting up as it spills into the gravitational event horizon. This image shows a stellar nursery, with brightly shining new stars being born at the edge of a vast region of gas and dust. This is the Carina Nebula, which is part of our own Milky Way galaxy. The level of detail showing structures and bubbles in the enormous cloud is finer than any other telescope is capable of. This image shows a dying binary star surrounded by superheated hydrogen gas and other materials spun off from the star's core, elements which will reform into other stars, planets, and, perhaps in time, living things. Webb, which was launched in December, is a joint project of NASA and the European and Canadian space agencies. It took more than 20 years to build and cost $10 billion. It's the most sophisticated space telescope ever made and makes observations in the infrared spectrum, a wavelength of light not visible to the human eye. Scientists were awed by the first images.
Maybe people in a broken world managing to do something right and to see some of the majesty that's out there.
Finally, this image gives a sense of the incomprehensible vastness of space and time. It is a deep look at a single area teeming with galaxies and stars. The light seen here originated 13 billion years ago, less than a billion years after the Big Bang. Scientists promise many more discoveries are ahead, adding immeasurably to our understanding of the universe that we are a part of. Rob Reynolds, Al Jazeera.
And let's bring in our guests. In London, we have Francisco Diego. He's a senior research fellow at University College London's Physics and Astronomy department. In Baltimore, Amaya Moro-Martin is an astronomer at the Space Telescope Science Institute and one of the scientists who selected the images we've just seen. And in Boston, Loeb is a theoretical physicist and professor of science at Harvard University. Welcome to you all. Thank you very much for joining us. First of all, Francisco, we had a little bit of an introduction there about what James Webb is designed to do. Tell us more about why it's often described as a time machine, isn't it, Francisco?
Well, it is a time machine. In fact, everything is a time machine because of the speed of light. We are always looking at the past. I can see the screen in front of me as it was probably a couple of nanoseconds ago. So, and the moon 1 second ago, and the sun 8 minutes ago, etc., etc. But looking deep into space, we are talking not hours, not days, not years, but not even millions. We're talking thousands of millions of years in the past, when the light from these distant objects that we see, especially in the first image that was released, left some of those objects more than 13,000 million years ago. So it is fascinating. Now we are looking, it's a time machine in the past, of course.
All right, we'll go through the images specifically in a moment, but Amaya, why is this a game changer?
I think it's a game changer because it represents what is the capability of this marvelous piece of engineering that James Webb is, right? And we selected images that represents a broad range of sciences that corresponds to the four pillars that in astronomy that James Webb wanted to address, from the very early universe to studies of exoplanets and planets in our own solar systems. And it's what we are seeing in these images and in this spectra is a promise, is the hope that we will be able to address many of the hot topics that are hunting us since we have a conscious of who we are, like, are we alone in the universe? How did it all started?
Okay, well, it's not often, I have to say, we have three guests who are beaming from the start of the show with enthusiasm at what's happening. Avi, how close are we getting then to the origins of our universe with this telescope?
Well, we think that the first stars formed around 100 million years after the Big Bang. Before that, the universe didn't have much structure in it, and we can look back in time and figure out our cosmic roots. There are questions about where we came from. Already in the first chapter of the Old Testament, let there be light. And in fact, with the Webb telescope, we could find the first light from the first galaxies, the first stars. And of course, the second fundamental question is, when was life created in the universe and how abundant it is around us? And again, the Webb telescope can look at exoplanets, can look at the nurseries of those planets, and inform us about the likelihood of finding life out there.
And Avi, just technically, it's relying on ultraviolet light. Let us understand why it's relying on ultraviolet light.
Well, actually, it focuses on infrared, which is not visible to the human eye, but stars, like the sun, they emit visible light. That's why we, close to that star, have eyes that are sensitive to visible light. However, as a result of the expansion of the universe, this light, the wavelength of the light, gets stretched by the cosmic expansion by a factor of 10 to maybe 50 for the earliest stars. And as a result, the wavelength goes into the infrared band, and that's where the Webb telescope operates. I was on the first advisory committee that designed this telescope, and the goal was to be sensitive to the light coming from the first stars. And the first stars are quite different than the sun. They were more massive. They emitted primarily ultraviolet light.
Okay, and Francisco, I just wanted to ask you, before we look at the photographs, that NIRCam that took these images, it uses something called coronography. Just help us understand what that is.
Well, no, these images they're not using the coronography. The coronagraph is an instrument that simulates a solar eclipse or a stellar eclipse, because when you have a solar eclipse, you can see the corona, which is the outer part of the atmosphere of the sun. So describing an instrument, designing an instrument that is able to do that optically, you can block the light of a star and produce a kind of artificial star eclipse, if you like. So you can see not so much the corona of the star, but any objects, any debris, any kind of material that will be forming a new solar system. That's the technique of coronography. But none of these images have been, so far, they have been produced by that technique.
Amaya, you were involved in selecting these pictures the first pictures that have been released. We're just going to have a look at them now. The first one is this one called Webb's First Deep Field. Could you just help us understand what we're seeing here and those red arcs, and how long ago was it?
Here we are probably one of these faint blobs. All the blobs here are galaxies. The only stars that we can see in this image are those that show this diffraction pattern that looks like a snowflake. Those are nearby stars, but all the other fuzzy dots here are galaxies. We have actually taken a spectra of a dozen of these galaxies, and the oldest one that we've seen emitted its light when the universe was about 1 billion years old. So when the universe was very, very young. But probably one of these fuzzy galaxies is the farthest away that we've seen. We just need to wait to analyze the spectra. And what analyze the spectra means is that we break the light that comes from these objects into their wavelength, into its different colors. And in this, we can see the fingerprints of different types of atoms. So we can learn about the composition of these very early galaxies and how during the evolution of the universe, these galaxies, these newly formed stars contributed to the chemical composition on the carbon, the oxygen, the nitrogen that we have in our bodies was not formed at the beginning. It was formed, it resulted from the nuclear processes that happen in the stars. So it's a wonderful machine to see how these elements appear in the universe and how these galaxies evolve from the very early ones to the ones we have in our local universe.
And Avi, this Southern Ring Nebula I've seen described as a stellar graveyard. What is that showing us?
Well, when a star dies, some of the mass of the star gets expelled. That's what will happen to the sun. It will eventually use up all the nuclear fuel that it has and will not be able to burn nuclear fuel. A star is simply a nuclear reactor held by gravity. So at the end, the star will cool off, but will send out some material to the so-called interstellar medium, and that creates these beautiful sort of silhouettes that we see here, where the interaction of this material with the surrounding medium creates these beautiful rings. And that's the future of our local neighborhood. I would like to emphasize also that in the image that Amaya was describing before, we tend to keep our eyes on starlight, those islands that are bright, but there is a lot of darkness in between them. And the reason I emphasize that is actually what we see is just the tail of the dog. Gravity is dominated by dark matter, which makes up these dark regions between the galaxies, and we still don't know what most of the matter in the universe is. So in a way, the message is that we should explore the unknown. Our knowledge is an island in an ocean of ignorance.
And just very quickly on dark matter, this I'm reading is like a sort of a theoretically influential sort of cosmic scaffolding. So do you think Webb might be able to uncover the mystery of dark matter for us or help us uncover it? Avi?
Well, Webb is just looking at light, okay? And so that informs us about properties of the dark matter. We can find the nature of the dark matter either by detecting it through laboratory experiments, like the Large Hadron Collider was trying to smash particles and generate some dark matter. Unfortunately, we didn't. Another approach is to see some signatures of dark matter in the light that they will reveal its identity. I don't think the Webb has a necessarily better chance than ground-based telescope to do that, but it will definitely inform us much more about the early universe. And the very first galaxies that formed tell us something about the dark matter, yes.
Okay. And Francisco, we're going to look at WASP-96 now while we talk to you. This is capturing the signature of water around the planet. Is Webb going to help us look for worlds like Earth that could support life? Because this is what a lot of people are really, non-scientists, really fascinated by.
Well, yes. I mean, the Webb Space Telescope with the spectrographs can detect the fingerprints, as we have said before, the fingerprints of chemical elements in the atmosphere of these planets. So presence of water in the atmosphere of a planet is a very good condition that we need in order to have life on a planet. The holy grail of astrobiology will be to detect not only water, as we see in this picture, but free molecular oxygen in the atmosphere, because that will be the signature of produce bio processes, especially photosynthesis. So far, molecular oxygen hasn't been detected, but the James Webb may be able to do that, and that will be a major thing. There are several missions, one of them actually from my institution, UCL, that are going to exactly examine the atmosphere of extrasolar planets, that we have so many. And it's a hard work in the future.
Okay, Amaya, the last two we'll quickly go through with you. Stefan's quintet, this one that's almost 1,000 separate image files. This is, I've seen described as galaxies locked in a cosmic dance. Go through that one with me quickly.
Right. So this is a mesmerizing dance of destruction and creation at the same time, because this arc that you see between the galaxies is really pockets of a star formation that has been triggered by these two galaxies interacting. This is a wonderful laboratory to study how galaxies interact with each other, because this is relatively, this complex of galaxies is relatively nearby, but in the early universe, interactive galaxies were very common, and this is actually how galaxies grew. So studying this type of interactions can help us learn how galaxies change from the very early universe and how they compare to the ones that we see today.
And lastly, the cosmic cliffs in the Carina Nebula. This one looked like craggy mountains. This is the most, seems to be the most arresting image. What have we got there?
Well, I have to say that I had the honor to present this image at the event that we had at the Science Space Telescope. And this is just amazing. What we see here that looks like a starry night, this is really the edge of a nebula where countless of stars and planets are being born. The high mass stars that are the hottest and that have very strong radiation and stellar winds have already formed at the top of the image, and they are basically eroding little by little the nebula. And we can see actually a mist that is lifting. This is really hot gas and hot dust that is being evaporated from the nebula. But all this destruction is happening at the same time that countless of stars and planets are born. And you can see this in these pillars that we see in the nebula, that are areas that are more dense and are resisting the erosion. And because they are more dense and they are affected by the radiation, this also triggers instabilities that makes the densest regions collapse. And then we can see outflows coming from stars that are in the process of creation. So this image is not only absolutely beautiful, but it's also full of new beginnings. Okay.
Well, Avi, over the next 6 months, we're going to be seeing the results of studies from NASA's early release science programs. This is only the start. What else are we to expect?
Well, first of all, we can get a much deeper image of the universe. The first one was just half a day in terms of looking at deep into the sky. And I'm sure that it already contains new information, because the telescope has 7.3 times the area of the Hubble Space Telescope. The fundamental thing we need to keep in mind is nature is much more imaginative than we are. And therefore, we have to look. And just by looking, we will discover new things. There is no doubt in my mind that the most exciting discoveries are yet to come that we cannot even imagine at this point. Even the deep field of the Hubble Space Telescope was not conceived when the telescope was constructed. Nobody thought that it will be that way. And so let's just stay tuned and be humble. A sense of cosmic modesty is in place because the universe surprises us very often. So let's just look and enjoy the show.
Francesco, 2 of the studies are devoted to exoplanets, including the TRAPPIST-1 system. Why is this generating so much interest?
That system of extrasolar planets is extremely important because it has planets which are very similar to the Earth, and they are also what is called the Goldilocks zone, which is a zone around the star when you can have liquid water on the surface of a planet where the temperature is such that it's not too close or not too far away, so the water can remain in liquid state on the surface of the planet. So this is why that system is so important.
What's next? How long can we hope that the telescope will keep sending us pictures for?
The telescope was designed to last a minimum of 5 years, but an expected life of 10 years. But thanks to Ariane, the launch was so efficient that a lot of fuel was conserved, and the expectation is that this telescope will last for 2 decades. So as Avi said, there is plenty of room for the unexpected, that it is really these unexpected discoveries that many times trigger those giant leaps in knowledge.
Avi, it did seem to be a flawless launch. But what are the risks to the telescope, though, while it's in orbit, the cosmic dust hitting the mirrors, that sort of thing? What have we got to be careful for?
It's those micrometeorites. One of them hit one of the segments in May, and we just keep our fingers crossed that not too many will hit the telescope during the lifetime, because it obviously that will be the biggest risk for degrading the optical capabilities of the telescope. These tiny micrometeorites that create a small crater on the surface. These mirror, the primary mirror is made of beryllium coated with gold. And, we want to keep it as clean as possible without much damage. So I should mention one more thing. We focused on the most distant sources of light in the universe. I should say that also the nearest ones are quite exciting, and that's a subject that Amaya and I hold very dear to our heart. There is a chance of interstellar objects that enter the solar system, and the Webb telescope is 1 million miles away from Earth. So if we look at a nearby object with Webb and with ground-based telescope, we would see it from different directions, allowing us to pin down the three-dimensional trajectory of the object to an extreme precision. Never before did we have a telescope so far away from Earth that allows us to triangulate the location of interesting objects like those that come from outside the solar system.
Francisco, are you surprised there is still much left to be discovered? Is there much left to be discovered?
I think when we are talking about science in general, there is always new to be discovered. We don't know what is going to come, but we know it's going to be fantastic. These machines, the Large Hadron Collider, the James Webb, they are really expanding our knowledge of the universe in the microscopic way and also in the macroscopic way. The discoveries are going to be amazing. We can more or less predict. We know more or less how the universe works. For example, this thing about dark matter, which is a major, this is why we call dark matter and dark energy. If you see the first image that was published by NASA, well, you see a lot of concentric structures around this cluster of galaxies, which is relatively close by. And in the far distance, there are many more galaxies that are distorted by the gravity of this, following the laws of Einstein, the distortion of light that is making these distortions because of the mass of the galaxies, but because of the mass of the dark matter, which is around these galaxies as well. So who knows? I mean, we are going to discover amazing things. The new generations of astronomers are going to have a very challenging but very rewarding time.
Very quickly, Amaya, about those new generations of astronomers, how much feedback have you had from the young people who are going to be making these discoveries in the future? How important is this?
I think this is very important because as what we have learned from Webb, from Hubble, from the Hubble Space Telescope, is that the images that Hubble has produced are now part of our subconscious. It's how we imagine the universe. So I think Webb, with its extraordinary capability, also is going to be, part of our subconscious again. Is going to even increase this imagery, right? Adding more colors, adding more information, going deeper in the universe. So I think astronomy is such a great hook for the youngest generations to be attracted to STEM disciplines, to the science, mathematics, engineers. So I think that's one of the most valuable things that Webb can contribute to.
Well, I'm afraid our 30 minutes seems to have gone by faster than the speed of light, but thanks to our stellar guests, Francisco Diego, Amaya Moro-Martin and Avi Loeb. And thank you, too, for watching. You can see the programme again anytime by visiting our website, aljazeera.com. And for more debate, go to our Facebook page. That's facebook.com/AJ Inside Story. You can also join the conversation on Twitter. We are at AJ Inside Story. From me, Bernard Smith, and the whole team here in Doha, bye for now.